konservieren. Wir könnten uns lieben und aus den Augen verlieren. Ja, wir könnten Vorurteile revidieren. Wir könnten Pole schmelzen und schnell evakuieren. Oh, wir könnten, wir könnten!
Ich wache auf, aus Schlaf ist an, der Tag am Traum, Friedhof fängt an. Hier liegen die großen Ideen, von denen nur Worte übrig stehen. Wir setzten Segel um die Welt, auf halber Fahrt sind wir zerschellt. Schwimmen mit dem Strom im Rettungsboot, Halleluja, der Traum ist tot. Wir haben überlebt, oh, wir haben überlebt. Sing Halleluja, sing Halleluja, sing Halleluja, sing Halleluja. Er gibt kein Laut, es platzt kein Traum, weil ihm keiner glaubt, bleibt ihm kein Raum. Ich bin soeben aufgewacht, ein Auge weint, kein Auge lacht. Wir kamen mit nichts in den Händen und werden auch nichts mitnehmen können. Nun sind wir hier, wo Träume enden. Halleluja, fang an zu singen. Wir haben überlebt, oh, wir haben überlebt. Sing Halleluja, sing
Sorry if you're watching. I was just handling some logistics for this YouTube channel. How do I get a link to this video? Webcam, manage, cancel. How do I get a link to this guy? What if I do incognito and paste it here? Nope. It's kind of an oversight by YouTube that you can't just grab the link of a live stream. La, 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 la. Pseudo Plato. That's not me. Pluto. There we go. Well, my live stream doesn't show up. It's ridiculous. But copy link. What we're gonna do is just promote this to my friends. To the advent of code subreddit.
Freitagabend, 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 Freitag in der Innenstadt fahren junge Männer. Autos, die
Live.
ihnen nicht
Okay.
gehören.
Apply, submit,
Sie werden heute Nacht so
and we'll do watch people code.
schwören, irgendwo im Gewerbegebiet.
Watch people code. I've actually never been to the subreddit except for posting this stuff.
Kannst du mir was verkaufen? Freitagabend.
I will say, this is kind of a peek behind the curtains, but a lot of, like most of my video views did not come from the YouTube algorithm. It actually came from posting it to the relevant subreddits. Like the Evangelion keyboard, I posted that to Reddit Evangelion and like the keyboard subreddit. The OBS thing, I posted to Linux Gaming. And so like my best, most watched videos are the ones that got like cross-posted onto Reddit. And so a similar thing is that when I launched my newsletter, and again, things I actually write about, is that I'll actually cross-post that onto places like Y Combinator and maybe Reddit as well. Days 3 and 4, and we're doing Ruby and CPP. Yeah, but I thought I would actually this is live, by the way. Yeah, usually people on Reddit are pretty toxic, but hopefully if you're trying to promote your own stuff, you're thick skin. Yeah, kind of a recap. So yesterday, we spent most of the time trying to do day 1 in Elixir, just without knowing any Elixir at all, which was, in retrospect, kind of a mistake, because while it's kind of superficially like similar to Ruby in terms of like syntax, it's very much just like a different syntax on top of like more like pure functional languages like Racket or Scheme and stuff like that. So how I've been doing to actually kind of supplement the spirit of Advent and Code is get onto Exorcism. So I've been going and doing these exercises on Exorcism using the syllabus thing, and then using those 2 books for reference, which were Joy of Elixir and Elixir School, and that's been going pretty decent. So I probably will make like a recap video once I get like enough of this done. But a good thing I like about Exorcism is that you do all the problems right for practice, but once you actually do the exercises, you can like click on it, right, and you can see your solution. And so you kind of have like your own like personal code library as well as like what other people did. So it's very nice for picking up new languages. It's just not very exciting. That's why I like Advent and Code, because like everybody's programming and it's a very exciting time. Yeah, so we have our coffee. I'm actually getting a video out soon, going over my coffee gear, because well, I'm getting pretty bored and coffee's like my new hobby, which is nice. I've graduated from instant coffee to like pour overs. I've finally seen the light. I have so much stuff. I have like pour over, I have a coffee grinder, I get like actual like coffee beans and coffee grounds now, so we've graduated. I thought coffee would be a nice departure from the beer of yesterday. But we're keeping the German playlist going on. It's pretty nice. So let's jump into it. If I remember, we started day 3. Where's it? Add code. 1. Day 3. I'm thinking once I get caught up, right? I could do things where I could try new languages. So like I've been messing with Crystal because I was like I was a little bit miffed with I was a little bit miffed with what's it called, Elixir, after yesterday, and I started digging more into Crystal, and it seems like a very nice kind of like companion to Go, where it's like the nice Ruby syntax and like the Ruby like coding style. But I think it's built off of LLVM, and it has the Go like not like Unix threads, but it has like its own runtime, and then you can launch your own special Crystal threads and communicate over channels, which is very nice. So it's like Crystal, I would say, is like almost like Go, but with Ruby syntax instead of C style syntax, which is nice. And another benefit of that is that with Crystal, you can link to C code, right? And you don't have that overhead that you usually do with Golang linking to C. So calling C from Crystal overhead. That's the problem with Crystal. It's not really hard to Google. I don't know, I probably can't find it off the top of my head now. Wanna lib. I mean, just the gist of it being like linking versus Go, right? If you do Golang C interop, maybe that will interop. Then we do Crystal Lang C interop, right? You have to use cgo, and that has an overhead when you're calling kind of like C or C++ libraries from Golang. I don't know like the exact reasons for that. Go references to C. No, we don't want that. cgo overhead. But yeah, the overhead of cgo has been kind of been documented a lot. And while like when I've used it, I haven't seen like too much of an overhead. I'm not like running like very performance intensive applications in Golang. But the fact that you can just like bind and hopefully there's no overhead that you have in Go, while still having like the Go niceties, really makes Crystal very attractive. So hopefully I'll be learning that along with Elixir this year. And then Rust, I don't know. Everybody's telling me I should learn Rust, but whenever I try, it just feels like where is it? Rust. It just feels like a weird like constrained version of modern C++. Like a lot of these concepts, right, are there in modern C++. A lot of the parroting that I hear from the Rust folks is kind of invalidated because they don't know modern C++. They like remember what they learned in university and they're just prejudiced against it. So like in my current job, we use like C++ 14, and that's very different from like the C++ 98 that we wrote. That at least I wrote like on my previous internship, and it's both been embedded devices, but two different very different styles of C++, and yeah, we don't use the smart pointers, right? But we use a lot of RAII or whatever, and custom types and stuff like that, and templates, and stuff like that in my current company. And then yeah, we have all these static analysis tools to make sure that we're not doing memory unsafe stuff. So Rust right now is for me, but I thought maybe I'd give it a go while I'm doing Elixir and other stuff on Exorcism. And I could always brush up my Ruby. So after Advent Code today, we'll probably go through some Exorcism stuff. You know, I'll switch ahead right now to Crystal, since when I was reading yesterday after the stream, I was very intrigued. Let's see how many people are here. There's... That's my friend Zach. Yes, it is. Okay, but enough chit chat. Yeah, let's get started. So where we left off, we were doing. We were doing this, right? And so we know our math that we want to do for our decimal stuff. So now we just gotta parse each string that we read in. So if we remember, right, we have our gamma rate and our epsilon rate, which are just inverses of each other, right? And then we're multiplying them by each other. And so we have one line, right? This loop we know is each bin number, right? And then in that, right, we want to go through each binary digit in that binary number. And yeah, so let's do that. So we need another if-else block. If not init, else no, actually no, we don't want the else block there. Because we're doing by line. So now go through binary digit. So basically we have this variable name places, right? But we want to set the size once we actually know the size of this, and we'll do this by actually getting the length of our binary number. So I think it's len bin. They do Golang. And we want to resize our slice. God, I'm so rusty. Or no, we want to make slice. Oh. Yeah, so make slice. Okay. So we want to enter our slice of string. Actually, no, we don't want that. We want our slice of int. And then we'll set our init to false, init to true, sorry. Init is equal to true. Count. So let's just not forget about count right now. Equals 1. And that's when we know how many binaries numbers to go over. And that's what we do when we see if the digits in the majority or the minority. And I'm guessing there'll always be an odd number of binary digits, basically. Sorry, not binary digits, binary numbers. But we should double check that. Do we already have our sample? This is our sample, right? And we want our sample, so bim samp.txt. Cool, and we don't need this column anymore. Go through binary digit. Yeah, we probably need to do that now. So for God, I'm so rusty. This is why admin code is good, guys. see. Yeah. So we have our index and we have our character, right? So now we want to just do if ch equals and then 1, right? Actually, does Golang have ternary? There is no ternary. Okay. I remember correctly. All we want to do there is we want to increment our places digit by 1. And actually, we don't need an else because it doesn't matter. And the places thing should 0 initialize. Right, and that should be good. And now we want to do is loop over our places count, and then basically create our gamma digit if the count, which is the number of ones, is greater than or equal to, or just greater than, because I'm guessing when there's an odd number of binary numbers, our count digit divided by 2. So we know our gam is going to be equal to 0, right? And then we're going to add all our binary digits. So for I, and then val in range, and then what do we call it? Oh, we didn't set it. Places. Places, right? Okay, so I think there's math.pow, so we'll just use that to be neat. So gam plus equals we'll set a new thing, not val. What is it? Dig is equal to 0, and then if val is greater than count divided by 2, we want to set our digit is equal to 1. There's always some like fancy bitwise math that you can do, but I don't want to basically do that. I am fine looping over. You can probably just do a loop, and then instead of doing this whole math expansion thing, you probably do like gam bit shift, and then you insert that thing. I'll actually give that a try after we know our loop works. We can get rid of this kind of math pow expression and just do the bit shifting. Golang bit shift. Bitwise and bitwise or bitwise XOR. Oh no, we also need our EPs. Right? So we got all zeros. And we got our shift operators. Left shift. So we need to do a shift and then a bitwise OR with the number 1. If I'm remembering correctly. Hold on. Yeah, so we just need to combine the shift with a bitwise OR of the value of 1. And that's how we do it bitwise. So let's actually try bitwise first, because it seems pretty simple. Let's not do this math. We'll hold it for later. Let's call emergency. Yeah, so we know that gam should get 1. There should be something where I can do bitwise not. Oh, I can do a bitwise not. Okay. So no, we don't need a eps. We just do a bitwise eps equals a bitwise not of gamma. Bitwise clear. Wow. Okay. Yeah, and then we just do our bit shifts now. Well, let's think, right? So first iteration, we have 0, 0, 0, 0. Second iteration, if there's a 1, we'll have 0, 0, 0, 1, right? And then, so you want to shift first and then do the binary OR with the 1. Otherwise, the shift is fine. So what we want to do is, we don't need the dig. Or do we? What's the dig? Yeah, we don't need the dig. So if we do gam 1, right? And then gam should get a 1. And then all we want to do is gam and then bitwise OR with 1. And that should work. You want to put that into SAMP. Everything should blow up. Undefined place. Should be places. Where is it? Evaluated but not. Oh. I wonder if I just can do this. That should work, right? I declared but not used. Well, since we don't use I, we can just do that. 0, that is not what I wanted. So I'll debug this real quick. But just as a cool thing for the Elixir folks who are using Vim, if you want Ruby syntax highlighting for Elixir, all you need to do is in your vim.rc is these 2 lines. So for Elixir files and Elixir scripts, you just set the syntax to equal Ruby. And that's for new file, for when you're opening a thing, and then I don't know what repost is, but it's fine. Zigzagune is best framework. Zach, we're talking about this, baby. I wonder if there's a Zig track on Exorcism. I don't think so. Nope. I wonder if our posts are doing anything. Oh, the one comment is me. Rough. Let's not go through my Reddit history. I just exposed myself by showing my username. Realize that. What were we doing? Oh yeah, why is my thing so bad? Well, the easiest way to do is this is print ln of gam. Like one of them just might be 0, and that might. That's not what I wanted. 0 and -1. That is definitely not what we wanted. So why is our gamma equal to 0? Let's see. If val is greater than gam only equals 1. We'll see how many we should print out our vowels basically. Right? If we're doing the counting wrong, then that'll be very obvious. What? We're not iterating? Uh-oh. Why are we... We're not doing anything. Zooey mama. Yeah, so our places thing doesn't have any, so... Let's see. I want to see what the len of places is. Zero. Okay, so we're not... Well, what's the... Let's print out the len of our binary number. Because it could be that our slice is fine, we're just... We're not even printing that. What? Are we even reading all the numbers? Oh no, it's Ben. Yeah, we're not reading anything. Nope. I swear, I just need one thing. Yeah, just need one. So our scanning's not working. Just interesting. It's kind of frustrating. I'm a doofus. I'm a doofus. Yeah, that seems right. And Zooey Mama 0. Wait, why is it still 0? What? Oh, because we're doing Len places. We need Len Ben. But it seems to be fine. But we're getting negative numbers. Is it because it's 2's complement or whatever? Five. I think it might be 2's complement. That's what we're getting. Yeah. If we do... Hold on, let's go back to the example, because... Five bit zeros and 7-bit ones. 7-bit was 1. First bit is 1. Wait, we got that the opposite way around. They're saying Zooey Mama 5. But it should be 7. Low-key kinda sus. Wait, yeah, what? Hold on. Five, 7, 5, 8. That's totally wrong. It should be... One, 2, 3, 4, 5, 6, 7. Yeah, it's doing 5. What? Why? But there's 5 digits. 1, 2, 3, 4, 5, 6. Excuse me? Oh no, is there a Zooey Mama before that? Yes, there is. Okay. Okay, that helps with the confusion. So I think it is just 2 complement. Yeah, 7, so we get a 1. 5, 8, so then we get a 1, right? 22. Get 22. And then... or 9 in decimal. Yeah, so... Golang, decimal. Oh, if we make it unsigned, then we should be fine. Where's the make?
Lass uns heute noch zum Mars fliegen. Einfach in dem roten Sand liegen. Mein Raumschiff steht für uns bereit. Komm, wir verschwenden keine Zeit. Das muss doch keiner mitkriegen. Lass uns heute noch zum Mars fliegen.
I know we can just make count also uint. Where is it? Wait, why was it? Oh yeah, because val is okay. So where's count? Was there a way to hint? That's not gonna work. Let's do it. Let's cast it. Excuse me? How did I delete that? How is it still negative? Oh, I know. That was... We'll get there. We're just gonna toss in uints until we get it, guys, okay? Please. Pain. Pain. Wait, no, we shouldn't. No, it should be Gam should be fine now because Gam we're making into uint. No, it's not. Jeez. I'm starting to think it's not worth it.
Komm, wir machen Urlaub im Containerhafen. Komm, wir machen Urlaub im Containerhafen von Venedig. Komm, wir machen Urlaub. Komm, wir machen Urlaub. Immer auf der Hut, vor der Hafenaufsicht spielen wir nachts im Flutlicht.
Wait, why?
Und ich verlauf mich zwischen meterhohen Wänden aus Stahl. Im Abschnitt C vom Containerterminal.
Wait, where's our knot? Did I just misread this? Oh, okay, we need to set the number of bits. Ah, this is easy. Okay. 5 digits. It's Lenny. We can just do a literal. Okay. Yeah, so what we want to do is do we want the not GAN, but then we also want to do ASP is equal to the bitwise and of the literal 1, 2, 3, 4, 5. Yes. You kidding me? This is a fun. If I did this the normal way, I'd be fine. But this is a fun learning experience in Bitwise. I can only see in your. That is not expected. Nah, man, it's up to 1080. Come on. Let me check on my phone real quick. Shout out to Zach for being my only viewer. What did I set the quality? What we'll do is we'll print out in binary and just see what we're working with. Sorry, what? Add leading 0B for binary. Percent hashtag B. Percent hashtag B. I'll take your word for it. Did I forget the comma? Yes, I did. Welcome to the new line. Why is there no new line? I think it is this one. I did that. Yeah, I'm baffed. Now we know our problem. Hold on, how do we do this? How do we do a binary not using just literals and this? So we can do
verletzlich zeigen und die Hoffnung nicht verlieren. Wir können es versuchen,
we can do the XOR of 1111 basically, I think.
Mut machen, die guten Seiten
Let's try that.
uns verbünden, statt aufeinander loszugehen. Wir können wählen, ich entscheide mich für die Liebe und für die Menschlichkeit.
How do you do XOR?
Nur wenn ich geliebe, hört auf, ein Mensch zu sein. Ich entscheide mich für
XOR carrot.
immer auf mein Herz. Wir sollten anfangen, uns zu lieben.
I swear if you forsake me.
Wir sind es wert. Es ist mir egal, wie oft ich selbst den ganzen Hass,
Pain.
am eigenen
Cringe.
ertragen hab. Es ist mir egal, denn wir haben die Wahl, die ganze Wut,
At this
die Ängste abzulegen.
at this point it's useless. I'm sure there's something that I need to do to
Lasst uns zusammenführen, was längst zusammengehört. Und nie wieder wegsehen, sondern voneinander lernen. Und wenn es
yeah, I'm sure there's something I need to do to like set the number of bits. Hold on.
bleib weich, ich entscheide mich für die Liebe und für die Menschlichkeit. Denn nur wenn ich geliebe, hört auf, ein Mensch zu sein. Ich entscheide mich für den Frieden und ich hör immer auf mein Herz.
No, I want to learn this because
Ich weiß genau, wir sind es wert.
oh no, it's not 0x, it should be 0b, I'm pretty sure. That's the problem. What?
Ich entscheide mich für
Yes! Yes!
nur wenn ich geliebt
Are you kidding me?
Mensch zu sein. Ich entscheide mich für den
Pain.
und ich hör immer auf mein Herz.
Oh, that's so dumb.
Fang uns zu lieben,
Ah, but we can't do lit.
fang Mensch zu sein.
Wait, hold on. It doesn't matter anyways, because we can't do literal because the number of bits varies, so we should just build up. We should just build up epsilon as we go. I'm so sorry for that, guys.
Wo ich ende, fängst du an. Ein jedes Wort von dir gesagt. Und ich erinnere mich daran, wie die Liebe klang.
Okay, and then what we want to do is if that's not true, what we want to do is epsilon exclusive or equals 1, basically. And shoot, we got rid of our printfs. But we got that. It was percent hashtag B, new line of gam, and we want one for esp as well. Yep, that's good. And we should be able to run that with input. Control A, Control C. We paste that in. And we run this with input. Let's see that gold star, baby. Yes. This part 2 is... Next, you should verify the life support rating. Oxygen generator. What? Your diagnostic report. Both values involves filtering out values until only one remains. You should start with the full list of binaries from your diagnostic report and just configure the first bit of those numbers. Then keep only the numbers selected by the bit criteria. The following. The bit criteria depends on the number already. The most common value in the current position, and keep only the numbers with that bit in that position. What? What? Oh, my head. Oh. You know, we need the code, and then we can mess around with it. Into part 2.go. And then we just get our... Yeah, cool. Right, and let's get rid of the Zooey Mama. Okay. So we got a nice looking input and we know our numbers, so we want to filter. Okay. The first bit of those numbers. Keep only the numbers by the good for the type rating. Discard numbers that do not match the bit criteria. First bit of those numbers. Okay, so we're basically taking a list, right? We have a list of all our values, right? And then we're filtering based off of our current digit, basically, and using the criteria. And then we're stopping once we have until we have one number left. And I think we're guaranteed that by the time we get to the end of the number, we should only have one number left. And so the 2-bit criteria is that most common value 0, 1 in the current bit position, and keep only the numbers with that bit in that position. 0 and 1 are likely common, keep the values with the 1 in the position being considered. Okay. To find a CO2 scrubber rating, determine the least common value. 0, 1, 0 on the position. Okay. Multiply the oxygen generator rate by the scrub rating. Okay. Oh, okay. So it's not that hard. It's just reusing the similar concepts that we have, but we have kind of like parallel lists of our binary numbers, and we're filtering them out based off of going over all the numbers again and again and again. And doing the bit criteria for each consecutive subset. Let me double check actually this part. First bit, 7 numbers. Second bit, other second remaining. Yeah, okay. Okay, cool. So I think that's the easiest way to do it basically is to have one go for oxygen and then one go for CO2, and then multiply the results, and then we can use the same function for both. We We just need to change the operator that we run for that. Or actually, we can use the same loop. I'm trying to think. Because the common operation for both of them is determining the most common bit within that subset. So if we can extract that part, then we could have a good thing. So how do we do that, right? We're using this. So what we want to do instead is that for each number, we want to insert into Oxy and into CO2 lists, right? And then once we have our list, right? Func that takes list of. Well, do we have filter? Yes. We have filter, slice and place. Huh? Oh, okay. Okay, so we just have to write our own filter function, I'm guessing. Yeah, okay. All the jokes. So what we want is a function most common bit that takes in a that takes in a slice of. I think we should just leave it as strings. So reference to string slice and then returns a char. Char? Okay. Byte, okay. And we'll just have this return null for now.
Ich stehe lautlos am Meer, höre nur die Wellen schreien. Sie kommen nicht mit hierher, lassen mich ganz allein. Diese Stimmen, die nie verstummen, stumm. Dieses ganze Rauschen.
Yeah, we want our
Ist auf einmal weg.
IDX uint. Okay. Right, and then we want to have our other function
Bin mit mir ganz im Rein. Bewerte nichts mehr.
filter
Es gibt kein Ja oder Nein. Diese
and
die nie verstummen, stumm. Dieses ganze Rauschen ist auf einmal weg. Dieses ganze Rauschen, diese ganzen Fragen sind auf einmal weg.
okay, we want to have that little premature optimization. Remember to quit early
Ich stehe lautlos am Meer,
when
mir ganz allein.
halfway
Sie stören
through
mich
the
an.
list.
Ich lass die Gedanken nicht rein. Diese Stimmen.
That's something that we could have used last time as well, but we didn't know. We didn't want to like load the entire thing into memory, but since we have to load the entire thing into memory and then kind of trim it down, I'm fine doing that. Since kind of like we were treating the previous one as kind of like a stream thing, while this one we're managing multiple arrays of this type. And the same thing, we're gonna take a bin nums that and then we want another IDX. And then we'll just pass in the byte and it returns nothing. And filters given bin num list. By if byte at index matches given byte. Cool. So now I have these two things, right? And this doesn't return anything, so we just return. These are two prototypes, right? We can just delete these. And then what we want to do is, was it oxygen times CO2? It's a common typo for me. Right, so we got that, right? And so I need to actually calculate these two values. So we don't want the count. What we'll use is append, basically. Bin nums O2. And basically we curse on it. So we want a driver function of this, right? So we'll just call this func drive. Wait, what was it? Most common bit. These common value, most common value. So it's not really most common bit. We want the inverse, basically. Okay, so we take in a bin nums string slice, and we don't want to. No, we do want to return something. We'll return a string. That'll be our final thing. Basically, for okay, so we didn't like the semicolons. Return bin nums at 0. Cool. And basically we'll do a recursive type thing. Recursive or iterative? We'll do iterative. So for when len bin nums not equal 1, what we want to do is most common, then filter. Let me turn that. We can do iteratively. No, we'll just have 2 drives, right? But we need a way. And where did the music go? Yeah. Alright, while I'm listening to a German playlist, 1, having a language that you don't understand playing in the background is less distracting. And 2, if I get copyright claimed, it'll only be like in Germany, which I'm not too sad about. And I guess third of all, I just really like the music. I love the stream going. 1 hour. Wow. We haven't even finished day 3. I'm slow. Then again, I'm talking through everything, which is fine. I think at 2 hours in, we'll just give up and then leave it for tomorrow. That's like my talking coding endurance. But let's take a look at day 4. Bingo. What? Okay. Draw numbers and a random set of boards. This reminds me of tic-tac-toe. So basically you would have a board implementation and then you just check each row, check each column, and then check the 2 diagonals, and then you just have your collection of boards, and then yeah, this would be a fun SQL plus one. It reminds me of a previous one. And then each time you draw a number, you mark that digit, and then yeah, this seems like a fun C++ one, or a fun Ruby one. This one, actually, no, I want to do it in Ruby. We'll make a board object and add these things where we have a running total and stuff like that. Yeah, this seems like a fun one. And a fun way to practice Ruby. So it'll be either Ruby or C++, this one. Hopefully we can get to it. We're close to be done with day 3. This part we could have done in Ruby. And the previous one too. But I feel like day 4 would be a good place to switch it up and go into Ruby. But yeah, let's have our 2 functions. We'll just have a string type. And we'll hard code it. Oxy, or what was the other one? CO2. And that is equal to most common bit, and it's using bin nums. And
Unsere Erinnerungen sollen uns nie im Weg stehen. Wir lassen sie gehen, gehen, gehen.
we want to count, no, IDX.
Du und ich, wir wandern. Und immer
And we'll have that invariant. We won't especially check for it, although it might explode. But basically, after the end of things, we'll increment our index. Right. And then, so we'll give it our index. And yeah, cool. And then we have our thing if type equals oxy.
verloren zu sein. Wir haben uns nicht gesucht, aber gefunden.
Type is already
Wir lassen uns gehen,
called T.
gehen, 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 gehen. Du und ich, wir wandern.
Yeah, I feel like the switching over to Ruby soon would be cool, just so I can practice. So with Ruby, right, I can switch it over to Crystal, and then with Crystal, I can try linking it with C++ that I write, which would be an interesting experience. I think I want to do that for at least like one of these days. So Oxy, right? We want to filter bin nums, given our IDX, and given our common bit. Else, we want to do the opposite. God, this is so jank. But what we're doing is basically just flipping it. And then we can store on the filter. So actually,
Ich denk viel zu selten daran, was ich eigentlich hab. Sie sagen, es wäre wichtig, wen man kennt und was man hat. Doch man kann es nicht kaufen, für kein Geld der Welt. Denn Liebe und Freundschaft sind das, was wirklich zählt. All eure Farben.
we don't need the else there, since we kind of just subsume this case in, right? Because we're kind of just co-opting the common bit, right? So if we have CO2, then we'll flip over common bit, and then we can still filter and then increase our index, right? And we stop when we filter enough to get 1, and then we want to turn that first element. Okay. And then what we want to do is we want to drive, right? So we'll set that equal to an empty slice, right? And then we have CO2 to and then what we want to do is that we just append, basically. And I don't care about the complexity of this. What's the pen over?
Danke fürs Hinfallen, für die offenen Knie. Und konnte nicht fliehen,
Sorry.
doch ich weiß jetzt endlich wie. Danke für die Zweifel, für die verschlossenen Türen.
It's slice and then the which are pending. Okay, that's the wrong thing. Oh, I got 2 viewers. Wow. Yeah. So what we want to do is we want to just append to that what we got, which is bin, and need that. Okay, and then so then once we read an entire list and append it to our 3 things, we want to drive basically. And no, we want to turn an int, right? And so what we don't want to return that, right? What we want to do is val that, right? And then what we'll do is we'll reverse the string and then just append it onto a literal. So val str was str.reverse. So there's no built-in string reverse? That is pain. We'll just do actually a reverse iteration. So for I is equal to len of bin nums 0 -1, and then while I is greater than or equal to 0, minus I. No, it's I minus equals 1. There's no minus, I don't think. And so that's our reverse iteration, right? So I is our index, and we're just going to reverse iter. And then we have our bitwise thing from last time. So what we want to do is val bit shift to the right and then or it, basically. That, and then val or equals 1. Why does that seem... No, it's not that. It's val equals to bin nums 0 at I equals to 1. Ooh, that might not work. I think booleans do a value to like 1 or 0. Do they? I guess we'll find out when it explodes. No, it wouldn't. Surely, right? Type untype bool into int. Is it true capitalized? I think.
Treiben einfach so umher auf einer kleinen blauen Kugel.
What's that?
Schwarze Meer. Wir sind wie blinde Passagiere, wissen nicht, wohin es geht. Und wenn man irgendwann aussteigt, will doch jeder sagen, wir haben geliebt, wir haben gelebt.
Just go in equal 1 or 0. Wait, hold on. We're overthinking it. What we can do. We'll keep that for now. If it goes wrong, then we'll come back to it. What is it? Percent hashtag B new line about, and then you can just return, right? CO2. I hate its name. Right, so we got those two, and then what we want to do is we want to drive. Basically, we got everything in here. We just want to do oxy is equal to drive of bin nums. It's not O2, it's oxy. Sir, drive signature again, drive, and then T string type, okay. Just go to our type of oxy. And then CO2. That's it. Print ln of oxy, and the same for our CO2. Cool. So now let's actually implement these helpers. So we got drive. We have a implementation of drive that might or might not work, which is fine. Relies upon filter and most common bit now. So what we'll do is places is equal to make a slice of not that that, and then the size would be of len bin. Yeah. Okay. And then we just need to iterate over this, just implementing the places. For I is equal to 0, I is less than len bin nums divided by 2 plus 1. I think that's a good one. And there's a special rule, right, about what we should consider if there's equal. If there's equal. If 0 and 1 are equally common, keep values with a 0 in the position being considered. Okay. Oh no, so we can't actually terminate early because even if it's all ones in the beginning, right? And then just 1 0 at the end. You don't know if the rest of the ones after that first 0 are all zeros, and that should actually be 0 instead of 1, basically. Actually, no. You just need to do, divide by 2 plus 1. And then if divided by 2 plus 1, the number of ones is less than or equal to the total length divided by. Yeah, that should work. Let's see if there's anybody here. Oh, we got David. Detected copyrighted audio? This is German, come on. Try this. This seems like more authentic Korean. Let's go. Okay, let's see. But yeah, look, going back to this. David, I know for a fact you don't know either. Let's see. Right, so we've seen the one past the halfway point, and we know that places at that's wrong. That's a lot better. And then we still need to iterate over places. Or yeah, so we have our nested for loops. And it's basically if it's not places that I, it's bin numbers. If bin dig equals to to 1, then places at so we actually want this j at j 1. Cool. So now we got our binary numbers half plus 1 through the list, and we have our ones counts basically. And we know that now, so now we can basically correct for I and dig in range places. If the value or the count is less than no, we want the most common bit in that one position. So we don't want to iterate over it. We just need to count for each one. So we have our IDX. So it's if you just need to replace dig with what that is. And we don't need places basically. We just need for that count basically. So we go through half plus 1. So if our thing, if bin nums at I and then at idx equals at 1, we get our count. Yeah, okay. And then we want to do our count basically. We want to do our count correction. If count is less than equal to len bin nums divided by 2, you want to return our character of 0. Else we want to return our character of 1. That seems right? Question mark? We'll add some more print debugs in there. But we have our count. We have our things, right? And then actually fine. And then filter is really easy. Ret is equal to string slice string empty, and then for blank we basically want to match, right? So bin nums. We don't want to return anything, we just want to do bin nums equals ret. That should be fine. And then basically all we want to do is ret equals append ret, and then actually want an if here. So if num and then the index of num at idx is equal to char. It's bugged. We want stage. Basically, we want to keep it if it matches the character there. And we'll append our num. Okay, and this should just work, TM. Missing function body. Where did we missing function body? 8, 27, and 38. 8, 27, 38. Sorry, what? Unexpected thing, expecting call or... Oh, does that have to be like explicit? Let's see.
가만 보면 너는 진짜 너무해 때론 날 무심하게 내빼 예친 채 불안함이란 벌을 내려줘 그럴 때면 난 길을 잃은 강아지가 돼 고개를 푹 숙인 채
Ah, so it's not like C++, you need just the pointer. There's no real reference thing. And then when you actually pass it in, then we'll take the dereference. Oh, the reference, and then we'll pass in the pointers, and then I think it automatically dereferences. Oh, and big doofus hours. Come on. Invalid argument bin nums for len. I swear there's something in Golang where it automatically does it. Okay, okay, so we have to dereference every single instance of bin nums. I could have swear there's like pass by reference in Go, but maybe I'm just bugging. Actually, we don't want this in Drive. Surely. Indexing. So I got all the thing. We're closer though. 1441. And undefined. Excuse me. Oh, yeah. Oxy and CO2. Okay. We don't need you, we'll just use it. Where's our other unit? Yeah. See, that gets rid of that. That does. Okay, so we just need the rest of the parens for index operations. Excuse me? Let's type int. What? What did I do? Yeah, okay, yeah. Makes sense. Okay, pain. These are terrible names, I'm sorry. But hey? 76th answer? No, that is not the answer at all. 23 and 10. Excuse me. 419. Oh. Pain. That's fine. I think if we finish day 3, then we can finish the live stream because it's almost 2 hours, I think. Is it still blocked? Come on. How's this copyright? Fine. There's a piece of paper. So it is filtering something, but I don't think it's filtering enough. 419. So I think the easiest way to do this is to in Drive. Is there a way to hold on? We got two bool sets. I'll just run this. Excuse me? Ooh, okay, that does give us a hint though, saying it's out of error. It's hitting an error though. Let's see. So 0, 0, 1, 0. See, that's kind of sus though. Hold on. I think it's Alt 1. Yes. Okay, cool. It would be helpful if we actually knew what the values were. So let's just do that. Obviously we know that's wrong. But we just want to double check if it's just like in the conversion process or we're actually filtering out the wrong number. That's why I'm doing this. Zero, 0, 1, 0, 0. That looks incorrect. Yeah. Okay. So we're filtering it out incorrectly, basically. Why is it so wrong though? Like that's my question. What we can do is after each filter, we can just print out when we know that our thing is correct in our bit shifting. So we know in our filter or in our min thing we're going wrong. So what we want to do is for each filter, we want to do of and that should clear things up. And then we want our num. Okay, so it's doing the opposite. We don't want to filter out those zeros to begin with. They're more 1 bits than 7 bits. Why is it choosing 0 though? Okay, so we know our filter is working. Just kind of boring. So our calculations are incorrect. This part.
서로 사랑하고 사랑받고 싶은데 So come to me, I come to back 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 방에 물은 전부 pass out 이건 나의 최선 죄로 나도 계산적이지만 네 앞에선 웃어 난 끝장보려 했어 처음부터 내 앞에서 질척거리는 남자를 경계하고 있어
Excuse me? Four? Why is it 4? Oh, it's 12. No, I'm done. We can't do the halfway thing. Yeah, we can't do the halfway thing. That's just a brain fart.
사람들이 말하더라 새것 마냥 길을 닫대 Innocent as newborn infant Baby 내게 착하더라 사람들이
Excuse me?
말하더라 전형적으로
First one looks right. 1001. This one looks sus though. Wait, no, that's wrong too. Sorry, what? Hold on. So count count is less than or equal to. That's right. No, we want this to be flipped, basically. It seems right. Oh no, that's not right. 23 and 10. What did we get? Totally wrong. What are we running first? Oxy, Sutu. So Oxy, we want the ones. And so if count is greater than that, then we want to turn 1, otherwise that. No, we don't want that, we want our sample. That doesn't seem right. 0, 0.
실은 너무 빠르게 뜨거워진 게 문제일까? 하룻밤 대화 몇 시간에 너와 나만 비슷하다 느껴 내 맘이 불안하단 이유로 그날 처음 본 내게라도 네가 날 안아주길 바랬던 걸까? 그게 지금의 문제일까? 우린 누구보다 오래된 것 같아 서로를 보는 눈빛이 조금 특별해 보인대 마냥 그게 쉬운 우린 더 욕심을 내 사랑을 쏟아내 적은 시간 안에 요즘 너에게선 그때 내 기억 안에 항상 행복해하던 얼굴을 볼 수
Okay, so our thing is
혹시 나와의 시간에 난 실증이 난 걸까 If we 우리가
IDX, count, and then is our count greater than that? That should help us. So 1, 0, 0, 1. Well, we should print out our results of filter, I think, as well. This will tell the story. So 1, 0. So it goes to the. Sorry, what? Oh no. Okay. I remember. I misread it. So it should be greater than or equal to. Greater than or equal to. Why does that default to true? What should I do? Excuse me? Most common dig is 1. 3. How is that? Excuse me. I think I'm getting the truncation, because 7 divided by 2 is equal to 3. So what I actually want is decimal division, and then doing the comparison. Or I can do some math. If the total, if the count minus the len, yeah, we'll do that instead of the division thing. I'll explain in one sec. So instead of this bit, right, what we actually want to do is choose 1 is equal to false. Then if, and what we want to do is if count is greater than or equal to our len bin nums minus count, choose 1 is equal to true. This song is a bop, dude. It's just I'm a boat. Yes, that's correct. Cool, and I can run it with input. I'm about to give up soon. I mean, we got the 290. Wait, we got it wrong again. No. How did we get 20? Excuse me? 10111, right? One zero one 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 or 23 in decimal. Uh-oh. So now our filter's working, but now we've uncovered that it's actually bad. Our bool set thing. Was it percent hashtag b slash n val? Zero one zero one. Yeah, that's good. Aha. We don't need the reverse order? We don't need the reverse order. Oh my god, I'm such a dingus. Yes, okay. So what happened was that we actually didn't need a reverse because we're doing the right shifts. And if this doesn't work, then I'm ending the stream anyways, because yes! Okay, day 3 is done. We'll tackle day 4 and day 5 tomorrow. I'm gonna stop the live stream, but I'm gonna practice up some Ruby for the bingo for tomorrow. And then I have no idea what day 5 is gonna look like, but we'll find out soon enough. But yeah, hopefully all 2 of you guys enjoyed the stream, and I'll see you tomorrow. See you guys later. Bye.